Hello everyone and welcome. In this lecture we will see the LU-Decomposition method to solve a linear system. So if we have a linear system Ax equals B, we can decompose this matrix A to two matrix L and U. This matrix is lower triangular matrix, and this matrix U here is an upper triangular matrix that is correspond to the row echelon form of the matrix A. So its form will be, for example, if we have a 3 by 3 matrix A, so the matrix matrix U will be with 1 in the main diagonal and any values here with zeros here in this position. This is an upper triangle matrix but with diagonal of 1, so that means we will get it from the matrix A as the row echelon form of the matrix A. However, this matrix L here is any upper triangle matrix, so here can be any value. They don't have to be 1 as in the case of U here, so they don't have to be 1. They can be any value with any value also here below the main diagonal and with zeros in this position. So this in the case of 3 by 3 matrix. And once we get these two matrices, this upper triangle matrix and this lower triangular matrix, we can replace them here, so they will be LUX equals B, and we can take this UX here and find a new vector Y such that we can replace it here that LU is equals B. And once we get the value of this Y, it will be easy to get the value of the X. So we first do the equation LU equals B, and then once we get the value of Y, we replace it here and we solve this equation UX equals Y, which will be easier. And it will be clear when we see the example in the next slide. So this is the same example that we have seen in the last lectures with the other methods. So when we do it in with this method LU-Decomposition, so we will require to decompose this matrix A to matrix LU. So for example, if we divide the space here to 2, so here will be steps to find U, and here are the steps to find vector the matrix L. So the matrix U here, we will get it from this matrix, and this matrix we will get it from the operation that we do in this matrix to get U. So this matrix will be in the form of A, B, C, and 0, 0, and here A, B, C, D, E, F, and we will try to get the values of this matrix. So here we want to get ones here, so this U here will be just the row echelon form of the matrix A, and we will try to get ones here and zeros here under or below the main diagonal and any values here. So first, to get 1 here, we'll divide here by 2. So we'll divide this row by 2 to get 1 here. So it will be 1, and here minus 1 over 2, and here 3 over 2. So this is the first step, and in this step we won't change the other rows, so it will be 4, 2, and 1, and minus 6, minus 1, and 2. And the value we here multiplied by 1/2. So in this case we multiplied by 1/2. Multiply this row, we multiply this row here by 1/2. So that means this value A here must be equals the reciprocal of this the multiplier, so 1 over 1/2, which is equal to 2. So that means we have get A equals 2. So we can replace it here so it will be 2 0 0 D, B, 0, E, F, and C. The second step now is to get 0 here and 0 here in this position, so we'll do it in the same step. And to get 0 here, we will add these two rows, but we will take -4 of this row, so it will be here. We won't change this row because we don't need to change it, and 3/2. And to get 0 here, it will be 4. It will be this row, for example, if we call it R2, and this one R1, and this one R3. So this row here will be R2 -4 R1. So R2 means 4 minus 4 times 1, which is 4 minus 4, which is 0, and 2 minus 4 times -1/2, which is 2 plus, here will be minus will be plus, 4 times 1/2 is 2, so 2 plus 2, which is 4. And at this position we have here 1 minus 4 times 3/2, so 4 times 3/2 is -2, -2 times 3 is -6, so 1 minus 6, which is -5. And for this D here, so this 4 we multiplied here by -4, here we multiplied here by -4, so with the multiplier -4, so we will take its inverse. Its inverse is 4, so the inverse of -4 is 4, so that means this D here is equals 4, the inverse of the multiplier here. And the same here, to get this E here, we will take here we have here -6, and we want to get 0 here, so it will be -6 plus 6 here, so we will multiply here by 6. That means -6 plus 6, which is 0, and here -1 plus 6 times -1/2, which is -3, so -1 minus 3, which is -4, and here 2 plus 6 times 3/2, which is 3 times 3, so it will be 2 plus 9, it is 11. And as we multiplied here by 6, so we will take its inverse to be E, so this E will be equals, so E here will be equals the inverse of this 6 here that we multiplied by it here, so it will be -6. So we will continue here in this piece. So the U here now is 1 -1/2 and 3/2. So if we write this like that, so -1/2 and 3/2, and this is the steps for U and the steps for L here. So here we get 2 0 0, and this D here now is 4, and this E here now is -6, and we still want to get B and F and C. So here we get 0 4 -5, and here 0 -4 and 11. So to get 1 here, we will multiply by 1/4, because here we have 4, and we want to get 1 here, so it will be, this matrix will be 1 -1/2 and 3/2, and here when we multiply by 1/4, it will be 0, 4/4 is 1, and -5/4, and here we won't change anything for now for these steps. And as we multiply here by 1/4, that means B will be the reciprocal of this multiply here, so it will be 1/4, which is equals 4. So B here is 4, so that means this matrix is now 1 2 0 0 and 4, and here b is 4, and 0 and minus 6, and we still want to get f and c. So to get f, here we need to get 0 here, so this won't change anything in these two rows, and 0, 1, minus 5 over 4, and here to get 0 here will be minus 4 plus 4, so it will be minus 4 plus 4, that means 0 here, and minus 4 plus 4 is 0, and 11 here it is plus 4 times this minus 4 over 5 over 4, so it will be 11 minus 5, which is 6. And as we multiply here by 4, we will take its inverse to be f, so f will be minus 4. So that means this matrix is now 2, 0, 0, 4, 4, 0, minus 6, and here f will take the inverse here is minus, or the negative here is minus 4, and we will still want to get c. So to get c here, we will just divide here by 6. So we divide this row here by 6, we multiply it by 1 over 6, and once we multiply it by 1 over 6, it will be 0, 0, and here 6, so it will be 1. Here is 5 over 4, and here is 1 over 6 times 6, which is 1. And as we multiply here by 1 over 6, it will be this c will be the reciprocal of this 1 over 6, which is 6. So that means c here is equals 6. So now we get the matrix. This is the matrix U, the upper triangular matrix, and this is the lower triangular L. So if we delete this space here, so now we have Ax equals b, and this A now is equals this LUX equals b, and we will define this equals y, so it will be L times y equals b, and y is equals y1, y2, and y3. So L here is this matrix, so it will be, when we multiply it by y, it will be 2y1 plus 0 and 0 here, so they will be equals b here, which is b here is 1, so it is equals 1, and here 4 and 4, so it will be 4y1 plus 4y2, which is equals b here is 2, and the last one here is minus 6y1 minus 4y2 and plus 6y3, which is equals 3 here. So that means y1 is equals 1 over 2, and when we replace here y1, it will be 4 times y1, which is 4 times 1/2, it is 2. So as we have here 2 minus these 2 here will be 0, so that means y2 is equals 0. And when we replace here y1 by 1/2 and y2 by 0, so it will be minus 6 times 1/2, which is minus 3, so 6y3 equals 3. Here minus 3, it will be 3 plus 3, so that means y3 is equals 6 over 6, which is equals 1. So now the values are equals 1/2, 0, and 1. But these are just the value of this y, and are not the values that are not the solution for the linear system that we have here. So we need to take this ux equals y, and u here is this matrix, so it will be x1 minus 1/2 x2 plus 3 over 2 x3 equals y here is 1/2. And this 0 x1 plus x2 minus 5 over 4 x3 is equals, here the value is 0, value of y here, and the last one is here is 0 and here is 0, so it will be this one here times x3 is equals the value of y3 here is 1. So now we get the values for x3, which is equals 1, and x2 here is equals 5 over 4 times x3, which is 1, so times 1, which is 5 over 4, and x1 here is equals 1/2 times x2, which is 5 over 4, plus or minus 3 over 2 times x3 here is 1, and plus this 1/2 here. So when we compute this, we will get minus 3 over 8, and these are the same solutions that we get in the last lectures. So x is equals minus 3 over 8 and 5 over 4 and 1. So when we multiply this matrix A by this vector x, we'll get this B here.